Alright, welcome to the first video of Chapter 5. The learning target we're going to be covering is learning target number 1. I can create a table of equivalent ratios and I can find the missing values. Okay, so go ahead and flip to the first page. Okay, I'll zoom in a little bit here if I can. What a table is it's just like regular ratios, okay? But it's just making a table out of it. So as you can see right here, my copy's kind of not great. Hopefully yours is better. I know you can't read any of this. I don't even care about that right now. But let's just look at it here and just be able to see. There's my table. So you can see where table comes from. And then you're just comparing the number of soda to juice. So I have 1 soda for every 3 juice. You see, it's just a ratio. And these are all equivalent ratios. The ratio 1 to 3, the ratio 2 to 6, the ratio of 3 to 9. You can see, what am I doing to go from here to here? I'm doing the same thing, times 2, times 2, okay? What am I doing to go from 1 to 3? You can't say 2 to 3, even though you are doing the same thing, but go to 1 to 3, you're going times 3. What am I doing to go from 3 to 9? I'm multiplying by 3. So it's just equivalent ratios, that's it. That's all this table is, okay? You're just showing it in table form. Okay, so this should be very easy. I don't think you're going to be confused at all. Okay, so let's go ahead and read this question. To make yellow icing, you're going to mix 6 cups of yellow food coloring with 1 cup of white icing. So right there, what I'm trying to get you to see is right there, that's a ratio, guys. That's to make this yellow icing, you're going to do 6 drops of yellow compared to 1 cup of white icing. I'll put white, CW for cup of white icing. Okay, that's just the ratio. How much food coloring should you mix with 5 cups of white icing? So it's just like a proportion, guys. Look, it looks just like a proportion. I didn't mean to draw that line. It's just a proportion saying, okay, these two are equal. They're equal ratios. What am I doing to go from here to here to here to here? Now, if we were doing this as a proportion, it would look like this. We have 6 drops of yellow food coloring per 1 cup of white icing. Okay, now we're going to set it up with our proportion and we're going to say, okay, are they giving us the actual number of yellow drops or are they giving us the number of cups of white icing? How much yellow food coloring should you mix with 5 cups of icing? So that means 5 cups of white icing goes there. You can see that I'm doing 1 times 5. So that means I got to do my yellow food coloring drops times 5. And I get 30. That's the way that I've taught you this whole time on review sheets and in Chapter 4. So now all you're doing is putting it in a table. That's all. But it's still the same thing. You're looking, okay, what did I do to my number of cups of icing? What do I have to do to my drops of yellow? Okay? So pretty basic here. And I'm fine with you guys. Like if it helps you think about it to go like this and do it that way, I mean obviously this wouldn't be there. Right? That's what you're trying to figure out. You're trying to say, what am I doing to go from 1 to 5 as far as my cups of icing go? And that's how we get 30. Okay? In a recent year, Joey Chestnut, if you don't know who Joey Chestnut is, Google him. He's insane. Okay, he's a professional eater. And he eats like 100,000 hot dogs all in 2 minutes. It's crazy. So anyway, Google him if you don't know who he is because it's crazy the stuff he does. It's pretty disgusting to be honest, but good for him. In a recent year, Joey Chestnut won a hot dog eating contest by eating nearly 66 hot dogs in 12 minutes. So, I mean, I haven't eaten 66 hot dogs in a year. So, in 12 minutes, I don't know how they do it. It's crazy. So anyway, what I'm trying to get you guys to see is that's a ratio. 66 hot dogs in 12 minutes. If he ate at a constant rate, determine how many hot dogs he ate every 2 minutes. So what we do is we got a ratio. Now, I'm going to do this in both ways just so you guys can see it. So I'm going to show you is the proportion. So that's my 66 hot dogs. So just forget about this for a second. Don't cross it off, but just forget about it, okay? 66 hot dogs in 12 minutes. That's my ratio. Okay? Now, in 2 minutes, okay, how you guys would do it is you would just look at it and say, okay, what am I doing to go from 12 to 2? Well, I'm dividing by 6. What am I doing? What do I got to do up here? Well, I got to do 66 divided by 6 and get 11 hot dogs. Okay, that's the way we would have done it. Now, what I'm trying to show you is, ooh, that's not going to work. what I'm trying to show you is it's the same process here. It's the same process, only now it's in a table, but it's the same thing. We have our 66 hot dogs in our 12 minutes. There's our ratio. Only difference here is we're not just going straight to 2. We're using that scaling method here. And we're basically saying, okay, I'm going to divide it by 2 and then divide it by 2. So I know now he ate 33 hot dogs in 6 minutes. Then I'm going to divide by 3, and then get 11, and then divide by 3, and then get 2. So we ended up getting that answer right here. They did an extra little step in there. They divided it by a number that wasn't the GCF of 66 and 12. So they did divide by 2, then they divided by 3. It's the same thing as what we did when we just went ahead and divided by 6 down here. We just skipped 2 and 3. We went straight to 6 right there and right there. So it doesn't really matter how you do it, okay? But in this case, we didn't even need to scale. We didn't even really need this, but it's kind of nice to know, okay, so we know that he's eating, 33 hot dogs in 6 minutes, okay, or 11 hot dogs in 2. Those are all equal ratios. That's what I'm trying to get you guys to see. Just like the ratio 4 to 6 is the same as the ratio 2 to 3, or the ratio 8 to 12. Okay, they're all the same. You're doing the same to the top to the bottom. They all equal each other. Okay, they're proportional. Okay, let's go on to the next one, maybe the next page. Yep, let's go on to page 3. Okay, Joe mows lawns during his summer vacation to earn money. He took 14 hours last week to mow 8 lawns. And again, I'm trying to get you guys to realize that is your ratio right there. So if we were doing this with the proportions, we would already be starting to do this. 14 hours in 8 lawns. And I hope you're writing this up here because I just want you guys to see it, that it's the same thing over and over again. Okay? At this rate, how many lawns can he mow in 49 hours? So this is how we would do it. If we were doing it as a proportion, now again, when I say we were doing it, did I skip one? Whoops. Okay, you guys are probably freaking out right now. I'll go up and do that one next. Sorry about that. Hopefully you guys figured it out. Regardless, so what we would do in this, we would look and say, okay, is there 14 times anything that'd give me 49? No, there's not a whole number anyway. So now we could use the method I taught you on review sheet number 13 where we cross-multiplied and then we divided. Okay, so when I do that, let me get my calculator out here. Okay, when I do that, I get 49 times 8 divided by 14, and that gives me 28. Okay, so I know the answer is 28 lawns, but I wouldn't know that without doing my cross products there. Okay, again, cross multiply and divide just means cross multiply and then divide. Okay, so we know it's 28 lawns. It's pretty easy. You could have also scaled back to find that you could have found the unit rate. You could have figured out how many lawns per hour or how many hours per lawn and then gotten there. But this cross multiply divide way is obviously, I think you guys think it's much easier. But now let's look at it in the table. And you are going to have to do this. I'm just showing you this so you can relate the proportion to the table. So in the table, let's go down here. You can see they started with the same ratio I did. They got the number of hours there. They got the number of lawns there. And I mean, it's the same ratio. Look, that's what I have. That's what they have. As you can see, they have it there. Now, they went ahead and they left a spot blank here. So I'm just going to get rid of this right now. I'm going to get rid of the 7. I'm going to get rid of the 4. And then I'm going to draw a line down the middle there, kind of showing you that they separated it. Okay. On the review sheet 13, I think you guys will remember this. The ratio was 3 boys to 9 girls. And the next one, it was asking for how many boys would there be if there were 15 girls. Well, I said you can't do that because we don't know what 9 times 15 is, or 9 times what is 15. So we had to do something that I called scaling. Okay, and what scaling is when you actually make an equivalent ratio, but you scale back to a factor of both the two numbers you have. So I know that 3 would have worked, and that's how we did it on the review sheet. I think most of you probably remember. And then you do the same to whatever you did at the bottom, you do that same to the top. Okay? So here, we know that we need to get to, I need to get rid of 28 because that wasn't part of it. This is all the information they gave us, right? They gave us 14 hours to 8 lawns, and then they said, well, how many lawns would it be in 49 hours? This is all the information they gave us. So we got to figure out what number I could scale back to here that would give me, what number could I scale to that would allow me to get, I got to evenly get to 14, but then I also got to be able to get to 49. And the first thing I notice is that 7 is a factor of both 14 and 49. So what would I have been doing to go from 14 to 7? Well, I would have been dividing by 2, as your notes say. Okay, so now we got to do the same thing here. Divide by 2 here, we're going to get 4. So 14 hours and 8 lawns. You could also do 7 hours of work, and you're going to be able to mow 4 lawns. Now we're going to scale forward because we're getting bigger. Now we'd be multiplying to go from 7 to 49. So we got to do that down here, and we get 28. It's the same answer we said it was, but this is just using the scaling method. Okay. Let's go up here and do this one real fast. Okay. Cans of corn are on sale for 10 for $4. There's our ratio. If we were doing it, we would say 10 cans for $4. Okay. Find the cost of 15 cans. And this is why I told you the cross products way is so much easier, because you don't even have to worry about it. You just line up your labels and then cross multiply, and then you divide 10. 4 times 15 is 60. Divide by 10, that's $6. I knew that. But there isn't anything there's not a whole number that multiplies to tell me that. I used cross products. But using the table here, you can see that they started with their regular ratio, 10 cans of corn, $4. They went ahead and scaled back to 5 because they knew 5 was both a factor of 10 and a factor of 15. And then they did whatever they did to the top. They went ahead and did that to the bottom to get their new ratio. And then they answered the question. That would cost $6. Okay? I'm hoping this is making sense. I'm trying to relate it back to the proportion just to show you guys it's no different. It's just in table form. Okay? On her vacation, Leia exchanged $50 American dollars and received 60 Canadian. Use a ratio table to find how many Canadian dollars she would receive for $20 American. So up here we're going to call this our American dollars, and then down here we'll call it the Canadian. Okay? We knew the ratio was $50 is $60. So that's the given ratio. So $50 to $60. Okay? Now, it wants to know how much Canadian, so this is what we're going to try to find out, would be if I had $20. How much would it turn into? Is there anything I can divide 50 by to get to 20? No, there's nothing. So we're going to have to scale. So what could I scale to? What would be a factor of both 50 and 20 that I could use here? And I know that they both end in 0, so I'm going to go ahead and scale to 10. You could also scale to 5. Okay? There's different options. There's not just one specific way. Now I know, okay, what am I doing to go from 50 to 10? Well, I'm dividing by 5. So what do I need to do to 60? I need to divide by 5. That's going to mean that for every 10 American dollars, that would turn into 12 Canadian dollars. Now, what am I doing to go from 10 to 20? I'm multiplying by 2. So what do I got to do down here? Multiply by 2. That is $24. So that's what the unit rate, or not the unit rate, that's what the ratio would be. 20 American dollars would be 24 Canadian dollars. Okay? And you guys can always do this. Take my advice. Simplify it. Simplify your ratio to where you actually type in 50, ABC, 60 in your calculator. You're going to get 5 to 6. Then take 10 to 12. 10, ABC, 12. Make sure it gives you 5 to 6. Remember, we did that in Chapter 4. You had to be able to tell me and I'm sorry if you can hear that. They're out there waxing the floors in the hallway right now. So if you can hear that noise, I really apologize. But just bear with me. If you type in 10 ABC 12 in your calculator, you're going to get 5 ABC 6. If you type in 20 ABC 24 in your calculator, you're going to get 5 AB 6. That's just a great way to check yourself right there. Because if they don't give you the same simplified fraction right there, then you've done something wrong. Okay, that's just a check. Okay? Here's what a proportion is. A proportion is a number sequence or equation. A number sequence or equation stating that two ratios are equivalent. You can write the proportion like this. When you work with proportions, with ratios, you're often looking for a missing number, which is what I told you. There are 3 numbers, Anyway, I don't know what I was saying because that I had to pause it and wait for them to get done out there scrubbing the floors or whatever they're doing. So I think hopefully the noise has died down. You can't hear. Maybe you could never hear it. I don't know, but it was loud. So anyway, remember I told you a proportion is used whenever you're looking for a missing number. I mean that's what we're really trying to gather. There's 4 numbers in a proportion. You have the first term of this one, the second term, the first term, and then the second term. One of them is always going to be missing, and it could be this one. It could be like that. It could be, it could be any of the 4. Okay? We'll talk more about that. We're going to use proportions for pretty much the rest of the year, so get used to it. A child's height measures 105 centimeters. Estimate her height in inches. Okay? So it's saying that 25 centimeters is 10 inches. That's the ratio that's given. Okay? It gives you that ratio, so it's saying we need to use that. I can't multiply anything to become 105. Now, you always could cross multiply and divide. Here, you could do 105 times 10 and then divide by 25 and get that answer. But let's just scale since it's in a table, and we need to scale when it's in a table. I see that that ends in a 5 and that ends in a 5. Let's go ahead and scale back to 5 centimeters. What am I doing to go from 25 to 5? Dividing by 5. So what do I need to do to 10? Divide by 5. Okay? And that's going to give me 2. And then what am I doing to go from 5 to 105? I'm multiplying by 21. And then I multiply by 21 here, it's 42. So hopefully you're seeing how this scaling business works. It's actually pretty cool. It's all about just whichever one you're trying to figure out, you're just trying to find a common factor that you can use there. So I think that's it for your notes. I want to make sure I didn't skip something. Okay, using scaling, that's what I was going for. So we covered the scaling, we covered everything. So it should be pretty easy, guys. I will see you tomorrow.